Hello and welcome to another episode of That's Absurd, Please Elaborate. This is a show with two science communicators who, well, we answer your questions. You send us ridiculous, absurd, off-the-wall, wild questions, and we try and find some science to answer them and give our listeners and or, whoever sends in the question, a satisfying answer. My name is Trace Dominguez. I am one of the two science communicators, and I'm here with my buddy Julian Huguet.
That's me! The other one!
He's also a science communicator.
Also here.
Julian, what's your question this week?
Oh, we're just diving right in.
No banter.
We
could do some banter. You want to do some banter?
No banter. No banter. We're going right to it.
Okay,
We've decided banter is over. It's a thing of the past.
2026. Let's the no banter podcast.
Trace, since we're getting down to brass tacks here.
Whoa,
let me
brass
tell you
tacks.
my question. My question comes from Steven. And originally it was a question that I posed to the Patreon in a poll. It was not selected, but Trace, I couldn't stop thinking about it.
Oh, that's actually a good sign, though.
So I came back to it. I came back to Steven's question, and Steven asked, how much water does it take not to get electrocuted?
Oh. Wait, what? I'm confused by this.
So Steven says, most people understand the implications of a toaster in a bathtub, right?
Oh, okay, got it. Yeah.
But how big of a tub would you need before an in-home electrical device falling in said tub would be safe for humans in said tub? And I thought this was great because, first of all, it reminded me of a meme, which is important to me. That's because that's how I think, right? But have you ever seen that joke that humans will not go into a swimming pool if a dead body is in it, but we'll go in the ocean and we know dead bodies are in the ocean?
I mean, I've never seen this joke, but I get it.
So there is a theoretical water to body ratio that humans are comfortable with.
Yes, I could see that. So if there is a bathtub with a dead body in it, I'm not going to be like, I'll hop in there.
Yeah, if
there's a swimming pool, if there's a hot tub,
yeah,
probably not.
Hot tub, still no.
Olympic-sized swimming pool, really big, probably not.
Nope, not going to jump in.
Wave pool at a water park, maybe. Where's the dead body? Is it way over there?
I thought it'd be way bigger as the waves slowly bring it closer to you.
Is the dead body at the other end of the pool? The waves are kind of gently rocking it back and forth near the quote-unquote shore. Yeah, maybe. Maybe I wouldn't even notice.
Maybe in the deep end, right.
Depends how big the wave pool is.
We definitely know, though, right? There are many, many shipwrecks and people taken down to the bottom of Davy Jones' locker.
There's submarines just imploding left and right down there.
It's quite a picture you paint of submarines. I don't think submarine accidents are that common, but sure.
They just don't tell you about it.
Just as soon as you never know. We keep sending submarines to go looking for the missing submarines, and then we just have more missing.
They just never come back, and they're like, well, they must be having a party down there.
It's a vicious cycle, yeah.
Don't want to miss out on the party.
All the submarines just popping like grapes down there. Huh?
Wow, that's dark. Just like the bottom of the ocean.
And yet you still take the family to the beach, despite the endless wave of sailors losing their lives down there.
I'm never going to think of the beach the same way again.
But that's the point, right? That's what this reminded me of. And it's true, though, right? Because there are electric eels, and yet I'm pretty sure I've climbed into a body of water that is connected to an electric eel somewhere.
Yeah, probably.
And I haven't died, right?
Yeah.
There must be a point when it's okay. So that's why I was really intrigued by this one, and I started looking into it. And Trace, here's the thing. I know my weaknesses. They are multitudinous. Geology, I think, is one of them.
Weakness.
Anytime I have a geology question, I feel a little bit, at sea, like a sailor in a submarine, just being crushed by all the water. Or electricity, I think, is another one, right? To me, electricity might as well be magic.
It does feel quite magical.
So I did some research and I found some interesting things on this too. And I also wanted to get Steven like a concrete answer. But before I go into that, let me also just put this caveat out there in the world. And that is, please don't take this as like a strict guideline on what to do.
Yeah.
Like,
nice.
I'm going to give you a number at the end of all of this. And that is not like permission to just put a toaster in one end of your very large bathtub and then be at the other end and be like, the man on the podcast said it was safe. Like, no.
Please don't do that.
Don't do that.
We're science communicators, but we're also idiots.
Yeah, that's an important thing.
You could say that about most podcast hosts.
I think if you're taking health and safety advice from a podcast, you've already messed up.
Honestly, wow. Broad-based, true. Based.
Yeah.
Yeah, totally agree.
Mm-hmm. So, started looking into it, and I found some interesting things. I was learning a lot about, like, conductance, right? Which is how easily electricity flows through something. It's the inverse mathematically of resistance, right? Which is how much a medium resists the flow of electricity. You've got conductance, which is represented in, electrical equations by sigma. And I found some cool stuff that were geology related, which again is a blind spot for me. I didn't know. But when we are, say, monitoring the health of streams and whatnot, conductance can be an important indicator of things like pollution. So, Trace, true or false? Water is a good electrical conductor.
I mean, I would think it would be. It seems like it is from the movies.
And you'd be wrong.
Yeah, I figured as much. Just by posing the question, I was like, it's probably not as much as I thought. But you would think that it is based on how much we talk about and see toasters in bathtubs and people being electrocuted in oceans and all sorts of stuff.
I mean, it's not really a fair question, and thank you for being my willing patsy in it. That was very big of you, and I appreciate you all the time for that.
And I'm happy to be one.
So, pure water is a bad conductor.
Oh.
It's got a very low conductance value, which, inversely means it's got a very high resistance if it's just H2O, right? Because you need free-floating charged particles in order to pass a charge along through it, right?
Right.
But as soon as you start adding things, ions, acid, salts, right?
Yes.
That is what allows electricity to flow. Those are electrolytes, like you might see on your Gatorade bottle, right?
Or in a battery.
Or in a battery. Yeah. That allows the electricity to flow. As soon as you start adding electrolytes, the conductivity of water goes way up. So conductance is measured in Siemens per meter. Siemens is a name, so don't giggle.
I was really trying not to.
So it's measured in Siemens per meter, and when we're monitoring, say, the health of water systems, right? Hydrologists will go and they'll put like a little electrode in the water and they'll measure how well it actually allows electricity to flow through it. And if there's a sudden spike in that value, that tells them, something must have recently been added to this water, like a possible pollution source, something like that. So it can be a pretty strong indicator of pollution. So that was a fun thing I was learning. That makes sense.
Yeah, cool.
I was also learning about how electricity kills you. That's less fun.
Oh.
A lot of it
I just realized I don't know how electricity kills you.
Do you not?
I mean, no. If you're in a bathtub and you electric the bathtub, it's not like you have a couple Frankenstein like electrodes that the electricity is like, I'm just going to conveniently go in here. Now I'm thinking like, it burns you. Your cells are mostly water, so... But, okay, tell me.
Okay. So, do you want to guess? What system do you think it interferes with that's kind of important to you not dying?
I mean, I assume your heart. Because it's electrically powered.
That's the main concern, right? Is your heart has cells in it that control basically the beating of it, and your body's all running on bioelectricity, right? Like ions with charges flowing in and out of cells, and building up a potential, a voltage, and releasing it, and that triggers your muscles to actually pump, all that sort of stuff, right? And it's important that your heart does it rhythmically, right? Blood comes into the aorta and moves down to the ventricles, and it keeps going in this normal flowing cycle. And if anything messes up that rhythm, if you get like arrhythmia, it can be fatal. Your blood is not actually being moved through your body anymore. And it doesn't take much electricity to do that. But again, this is where we get into kind of the electricity can be hard to wrap your head around, because we all think that voltage is really dangerous, right?
Yes.
When we see like, a high voltage sign, right?
Yeah. I mean, yes, when they're like 10,000 volts, but what I learned is in the documentary Jurassic Park, when Timmy was on the fence and he got zapped with 10,000 volts, he didn't die. Mm-hmm. He was fine. So I looked it up.
So it's fine. So based on the documentary,
Jurassic Park, it's fine.
Right. So high voltage is analogous to like high pressure of water, right? If the flowing of electrons can be likened to the flowing of water molecules through like a pipe, voltage is analogous to the pressure that's pushing that water forward, or it's those electrons through the system, right?
In this case, think about like poor little Timmy. He got a lot of voltage very quickly because of the high pressure.
But
yeah,
what's more a concern when we're talking about the risk of being electrocuted fatally is the amperage, right? The current, the amount of current.
The current capacity.
Right. And so current is analogous to like how much actual water is moving through it, how many electrons are actually flowing through it.
Right.
Voltage is how much pressure they're being pushed along with. Current is actually how much water is moving, how much electricity is moving.
The analogy I'm coming up with on the spot is you have a tiny little water gun that has very high pressure, and then you shoot it at somebody, and it's going to hurt.
Sure.
It's going to be a big deal.
It might sting.
It might, but if it has the same pressure as a fire hose. However, you have a fire hose with that pressure, that's going to be crazier. So a 10,000 volt high amp is a fire hose. 10,000 volt low amp is the same pressure as a fire hose, but is a super soaker, which wouldn't be great, but wouldn't kill you.
Yeah, it's when it's the fire hose is when it's actually starting to get dangerous, right?
Right.
And the reason water makes this more dangerous, right? Why getting wet, especially if the water isn't like pure H2O, if it's actually got conductive electrolytes in it, is it's going to lower the resistance for electricity flowing through your body, right? Flowing through your skin and then through the actual parts of your body, your blood, your muscles, your heart. So because it lowers that resistance, that means there can be more current flowing through you. This is Ohm's law, and that is that current is equal to voltage over resistance, right? Okay. So since the relationship between current and resistance is an inverse relationship, lower resistance means more current, and current is amps. So this is about the point where I was out of my depth.
Okay.
In this bathtub of electricity, and Trace, I had to phone a friend.
You did a journalism?
I did journalism. I mean, sort of, because I'm lucky. Because I happen to have married into a family of geniuses.
Oh,
and one of them, my brother-in-law, Derek, is a physicist. Not only that, he's one of the longest tenured listeners. I actually showed him the first episode of this show before it even released. And he was like, that's cute. But he still listens. Anyway. So yeah, I have two brothers-in-law, and they are both the smartest people I know. I just want to say that's like the most intimidating thing in the world.
Sweet.
So he's a physicist, but his specialty is electricity. He runs a laboratory where he hits like cutting-edge materials with lightning, artificial lightning. Yeah, and like films it on high-speed cameras and studies how the material is affected, right? This is his bag. And electrical safety is an important thing that goes along with it, right? Along with understanding how it all flows. He also has to take precautions to make sure that the laboratory that he runs is safe. So I asked if I could waste about an hour of his time, and he obliged.
Wow.
So the first thing he sends me is this list of equations.
Oh my, this is not intimidating at all. R equals 1 over several Greek letters, and then Santorini equals 0.1 milliamps, and then V equals 1 arrow 1. Okay, got it. Cool. Wow.
So some of this is familiar, right? Like the sigma is that conductance we talked about, the Siemens per meters, right? Like how conductive it is. And he's starting to make assumptions on, what the conductance of a human body is going to be. So we assumed it's like 1 Siemens per meter, that sort of thing.
Sure.
We've got Ohm's law there, the voltage equals current times resistance, and then, it rearranged. Then he had it just below that, J equals sigma E. That's Ohm's law again, but now we're talking about like vector fields, so he's already lost me there.
Oh, wow. Right? Okay. Yep, don't know what that is. Cool band name, though.
Vector fields.
I would go see Vector Fields. I bet you they're great. I bet you they would open for Chiverches. For sure.
It would be pretty good. So, it's definitely synth pop. 80s waves.
Yeah, right? It's like that.
But as he's showing me this, he's also drawing out like a whole diagram, right? And so we imagine a toaster in a bathtub, right? Or in a body of water. And he simplifies the toaster down to what it is. And Trace, in electrical terms, what is a toaster?
It takes electricity and it converts it to heat using like a high resistance wire, basically, right?
That's it.
So the wire has resistance, and so the electricity turns to heat and toasts your bread.
So resistance in a wire depends on a few factors, like how long the wire is, how thick the wire is,
what
right?
It's made of,
what it's made of. So when you look inside your toaster, you might see like coils, right? Like long coil. And that's so you get like a really long wire, but in the space of a toaster. Mm-hmm. And that'll heat up because it'll resist the flow of electricity and the energy gets wasted as heat. That's why you might also get burned by electricity, because if a lot of it is traveling through your body will resist the flow of it, generate heat, and burn you. That's how electrical burns can happen.
And how light bulbs work is it was able to resist enough that it turned to heat, and then got so much heat, turned to light, and then now we don't really need to do that anymore, thank goodness, and it saves us a lot of energy wasted as heat.
Exactly. Those are the old incandescent bulbs from Thomas Edison's day up until like 15 years ago, when we all switched over to LEDs, basically. Which is funny because, watts is a measurement of power, right? It's like how much energy per unit time.
You're going to talk about the 60-watt light bulb?
Yeah, right? But that's just how we're used to bulbs. And so even though the power consumption is like
6
nothing
watts, 7
compared
watts,
to how it used to be, the amount of light it puts out, and we just think of things in terms of watts, like the average person.
I've started seeing it more listed in lumens, which is, this is a total sidebar, but I've seen it listed in lumens and then like color temperatures with Kelvin, and I'm like, oh, this is great. This is so standardized. I know how all this works.
Every time I see a LED light bulb that's like 60-watt equivalent, I'm like, we're so dumb, just as a people, like
we've got a system
nobody
that
understands anything really, right? If I were to buy a light bulb that said 4 watts as a normal consumer, I'd be pissed. I'd be like, what do you mean it's only 4 watts?
Yeah, that's true.
Yeah. But that's more accurate to like the actual power consumption. So brother-in-law Derek takes the time to set up this schematic, right? He puts the toaster that he just represents as like a resistor in a bathtub. Not a real one, listeners, not a real one. Yeah. A drawn one on a piece of paper. So we're all safe. It's okay, right? And then he starts explaining some common misconceptions. And one of them that most people have about electricity is that it takes the path of least resistance.
Yeah, that's what you hear all the time. That's right. That's if somebody knows something about electricity, the path of least resistance is probably in the top 3 things.
Yeah.
Two things that you know about. A positive, negative might be the other one.
And it's one of those, sure, but that's not really right. Like it's helpful, but it's not really right. He says, in reality, it takes all paths available to it.
Right.
But just to varying degrees.
That actually makes me think that what it's probably really is like taking the path of least resistance at any given moment, because it doesn't like know the full path that it's going to take. It can't see it the way that we do on a macro level. It's like the electron is like moving toward, like the charge is moving toward whatever is the easiest path at that point. Or whatever, the most available, I guess, really.
I think of it, like all things when you start to get to like higher level physics, I think probability is an important part of it, right? And the path of least resistance translates to the most probable path, but not the only path, right? And so most of it will go path of least resistance, but not all of it. So,
cool.
The electricity can flow straight through the resistor, but it'll also flow through the water, arcing around the resistor. And so in his schematic, Derek drew these field lines for me, right? Representing the paths electricity can take. And he says, but the most dangerous place to be is like right in between the two sides of the resistor, right? Like right along that line, cutting it in the middle, because that's where the field lines of electricity flowing through are perpendicular.
Okay, so if I picture this, I would have like 2 bumps on either one on either side of the resistor. And the bad place to be would be in between them?
Yeah, along that line that is
perpendicular to where they are.
Right.
Okay.
Exactly.
Interesting.
Because that's where the field lines that are arcing are going to be perpendicular to like your heart, right? So you're going to get the highest possible density.
Got it.
When we talk about flux, right? That's like how many of these lines are going through a given area. That's where you have the greatest flux. Okay? So that is the spot where you might be able to get closer to it if you're maybe closer to one end or the other of the resistor. But if you just move more in between them at the same distance away, it's going to get more dangerous. So you'll have to be farther back from that, right? And then we make a lot of other assumptions too. So to give me the most conservative estimate possible, he says, okay, I'm not going to even imagine this as a resistor anymore. I'm going to imagine the toaster as like a capacitor, right? So no electricity flows from one end of the wire to the other end of the wire, right? They get to these capacitor plates and the electricity basically stops as the capacitor fills up with stored charge.
Right. Like an old school flash camera that like
that's right. All the energy just gets released quickly, right? You drop it in the bathtub and boop, it just goes around the capacitor plates. They go from one electrode to the other, one pole.
I thought you were doing anode and cathode, and I was excited to do my mnemonic. Hey, here's some electrons. Caught them. Cathode caught your electron, or caught your charges. Got it.
Least helpful mnemonics possible.
I just think it's great. I now know where the electrons are moving.
So, basically, we need to calculate how many lines are going to be going through a person's heart, right? We need to know the cross-sectional area of the heart, right? How many of these lines are going to go through it, what the kind of value of current is for each little line, and then we're going to add it all up and see if it reaches that lethal threshold. And that's when we know how far away something is when it's going to be lethal, right? So I saw a few figures quoted online on how dangerous, how many amps you can be near before it'll interfere with your heart's rhythm. I saw some things that were like 100 milliamps. Derek was more conservative. He said 0.1 milliamps. And he works with electrical safety. I'm going to take his word on this one. So 0.1 milliamps across your heart can end up being fatal. That's going to tell us how many lines can be going through the heart. Derek plugs all this into his Mathomatic machine.
Is it like a calculator? Are you talking about a calculator?
Yeah, well, it's fancy math software. And he uses a lot of the iHeart one.
iHeart?
Yeah, no, we're not a part of that podcast.
Yeah,
network.
we
can't
I
plug
think
it, right?
we can say that.
But it has like the area of the heart, the conductivity. You can see it all in the equation. It's got the permissivity constant, right, which is how easily electricity flows through empty space, right? All of this is things that very smart people figured out, all these constants. Anyway, Derek plugs it into a big calculator Torio machine, and also importantly assumes that we're dealing with American wall outlets, which are 120 volts,
yeah.
right? Europe might be 220 volts.
Right.
And if we look earlier in the equation, right, since current is equal to voltage over resistance, if voltage goes up, current's also going to go up.
Right.
So if this were like a European electrical socket, or Stephen, if you're planning on testing this, which for the love of God, don't
do it.
And you're in Europe, these numbers will be different.
They will be bigger,
more dangerous,
bigger,
worse. Also, we assumed that the heart is about the size of your fist. I measured mine.
Your
fist
heart?
has my fist, which by proxy represents my heart.
Yeah.
My fist has a radius of like 2 inches basically, and we approximate it as a circle, and that'll give us like, the cross-sectional area of the heart. We plug all this in, and we get this graph. Yes, pull the lever, Crunk. There.
That was unexpected, and I liked it.
Behold the dangers
Why
of
do we
electricity.
even have that lever? Okay, let me describe this graph for people who can't see it at home, because this is an audio medium, Julian.
Yeah. Is it? I'm just learning that
the
now.
The x-axis is exponent of 10 to the negative 1, 10 to the 0th, 10 to the 1, and 10 to the 2.
Right, and that's meters. So that's how far away we are
from
the toaster.
And then the y-axis is, it looks like I heart A. So a function of the heart itself.
That's
and I assume how many amps are
going
it.
through the heart.
And it goes from 0 to 30. And so the graph I don't have a cool name for graphs like you did last episode, but it looks sort of like a reverse hockey stick. The tip of the hockey stick is at 25, and then it has a precipitous drop and curve down around 5 where it really curves toward the bottom, and then hits about where 10 to the 0th is.
This is a logarithmic curve because current, like electrical potential, just like gravity, right? It's another inverse square law. We've talked about these things a few times on the podcast, right? But it means that the strength of it really drops off over distance because it depends on some number over the distance squared, right? So that's why you get this curve. And remember, we're looking for 0.1 milliamps, right? So 10 to the minus 4 amps on this graph, which isn't even represented on the y-axis here. So we have another graph. Now that you've seen the logarithmic one that is kind of more in line with how people think of graphs, let's show one that has log scale, so the line becomes a straight line.
So the line is a straight line. Now it's the same idea, 10 to the negative 1 up to 10 to the second, and then we have 10 to the negative 5th on the y-axis of amps all the way up to 10 to the second. So very small amount of amperage up to what is still relatively small amount of amperage.
Well, all the way up to 10 amps. That's
10 amps,
even beyond it, right? It's somewhere like 10 to the 1.5 or something
1.5,
like that. It's quite a bit, right? So that'd be
10
50.
amps is quite a bit. You're powering a good vacuum.
Right.
That.
So, 20 amps, you might be melting the wires in your wall, right? And then tripping the circuit breakers. So again, the amperage that we are looking for is 10 to the minus 4. If you go and see on my chart where that lines up, that's at about 10 to the power of 1.3 meters away, which is about 30 meters.
Oh, wow. That's farther than I thought.
I think that's reasonable. Derek asked me at the start of it, he goes, how comfortable would you be? Like, what size body of water, if you knew a live toaster was in one end?
How big a body of water would you?
How big would it have to be until you're comfortable getting in?
And this is in meters.
Right, this is in meters.
Not in like square meters, like area of a pool. You're talking about how many meters away you are. So if it's at the shallow end of a large swimming pool, a regular swimming pool is 25 meters for a lap, right? You do one length, you're 25 meters. And so that's still, you're within that space.
Yep.
I feel like logically, if there was there's a toaster in the other end, I'd be like, I'm going to be fine.
You know what? Yeah, no, I don't need to do. I'm going to run on the treadmill instead of swimming laps today.
See, I would just stick my toe in. I'd be like, no, I'm probably not going to feel anything.
Gotta know what it's like. Yeah. So according to this chart that he had made up, and we made some assumptions like how many resistors there are going to be in the toaster. We basically assumed one per each side of toast, and you're making 2 pieces of toast at a time, that sort of thing. So again, we made a lot of assumptions to get this number, but the ultimate number we come up with is about 30 meters, it looks like.
That's wild.
Yeah.
That's way further than I would have thought.
And that's, again, for 0.1 milliamp. Again, I've seen things that had the number of milliamps you could take higher all the way up to 100, which would be 10 to the minus 1 on this chart. And that would be within a meter, according to this line that we have.
Wow.
But we're being very conservative because, again, do not electrocute yourself to test out what you're learning on the podcast.
Regular high school-sized pool, if there is a toaster plugged in it.
And so
don't get in it.
So the last image that we were able to generate, though, shows like a clover pattern of the danger zone, right?
Wow.
Anything in red, that'll kill you. Yellow, probably discomfort. Blue, maybe you're tingling, maybe you're not feeling it, right? But as you can see, again, we're talking about that inverse square law, that logarithmic relationship between these things. As you're farther away, it's blue, 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 and then almost immediately yellow and red.
Yeah.
Right?
Yeah.
It goes from okay to not okay in a very short distance.
And you can really see that perpendicularity you were mentioning, right? There is this little, because it's a clover, in between the 2 clover leaves, you could ostensibly, don't do it.
You
could,
Stephen,
kind of tuck in there.
Right.
And it's the darkest blue, which means it's the safest place on the graph to be, which is don't do it.
When I got on the phone with Derek, he was
interesting.
like, it's an interesting question because there's a lot of complex geometry involved. And I was like, there's geometry, electricity, what? What? And this is what he was talking about,
That's
right?
cool,
And
man.
there's some things where, assuming too, like there's no additional, like a grounded drain that might also be drawing some current over towards it.
sure.
And if it's like behind where your body is, it'll make more current field lines travel through you.
Or
that
like
sort of
the
stuff.
lane markers aren't somehow grounded to something, because they might be metal or something, who knows?
Yeah, exactly. There are a lot of variables that we chose to ignore to get like the simplest answer. But still, I thought this was really fascinating. Oh, how dirty you are, right? If you're more dirty and you climb in, you'll make the conductivity of the water go up, right?
Whoa. So it's worse. Do you really want to
it'll be
shower
worse.
before you get an electrified pool?
Before you take your favorite toaster for a bath.
Take a shower. You should shower before you get in the pool anyway.
Yeah.
Nobody does, but you should.
You're supposed to, right?
Yeah.
Because it uses up the chlorine, because the chlorine reacts with all your greasy dirtiness.
Yuckiness. Julian, you did a video years ago that I'm going to bring up now, and you know exactly what I'm going to say.
I know, it's one of your favorites.
Just because it changed my life. Like, every time I enter a pool, a natatorium, I think about it. If you can smell the chlorine in the air, it's because it's bonded to something disgusting in the water and come out of solution.
Right.
Which means the pool is not necessarily dirtier, but like a lot more dirty things have been in that pool.
You need to basically bomb it with more chlorine. That's
Right,
what I learned
because
based
the
on the
chlorine
pool
is
cleaning company websites I learned this from.
so gross. Because so many pools, you go in the natatorium and they smell like nothing. And that means that the pool is clean, the air is clean, everything's clean. And the people that got in it were clean. But if it smells like chlorine,
it's dirty.
that chlorine is covered in gross. Anyway, sorry, go ahead.
Back to toaster baths. Yeah, I want to thank Derek for taking the time to explain all of this stuff. This was super helpful and fascinating. And yeah, Stephen, there's your very conservative answer that I do not recommend you actually take as gospel, but it's about 30 meters away or so.
That's pretty wild.
Of course, bathrooms now especially have a lot of what are called ground fault interrupter outlets, where they detect if the current flowing back into the outlet is lower than what was coming out of it, because then it knows that, that current's going somewhere else. And they are designed to shut off extremely quickly. I think it was like 0.4 milliseconds if I was looking at the number, and it was very, very short amount of time. So maybe you'll get a little shocked, but it won't be like long enough to actually cause your heart to go into arrhythmia and kill you.
And those GFCIs are now, at least in the US, they're supposed to be standard in a lot of places that are with water. Whereas like in the UK, you can't even put an electrical outlet in a bathroom. So, the different places have different ways of managing it. But I think it's very interesting. Thanks, Julian. And thanks, Derek, for thinking our silly little podcast was worth your time and compute power.
Wasting a whole hour of his day.
That's great. Really cool. Well, let's take a quick break and come back, and I'll answer a question about spaces.
Welcome back. I hope you had a pleasant toaster-free bath or something while you were gone.
I hope it wasn't too shocking.
Yeah. All right, brass tacks. Trace, question, go.
My question comes from Gerald, who sent us some audio.
Hello, my name is Gerald from the United States. My question is, how much paper would we save if we got rid of spaces and returns? Of course, this is a highly subjective question, but it came about because I was thinking about how the Japanese written language compared to English doesn't really use spaces. And then there is the matter of how I always try to maximize how much text I print out on my paper because I'm cheap. Thanks for answering my question.
I hear you. At-home printer costs are astronomical. That's how they get you.
So I thought this question was great. This is the kind of efficiency that communication in 2026 needs, right? Just gotta get rid of those spaces and just throw everything into one long paragraph, and then also get rid of the paragraph marks and throw everything into one long block of text.
That'll be readable.
It'll make everything easier. there is a generation of nerds who watched Captain Planet and would be like, yeah, wasting paper's terrible. Because you remember, like, the beginning and, like, Captain Planet, and they're showing all the different powers. And the gal who does wind, she, like, stands on the edge of a cliff. And then you see all of this office paper, like, swirling and coming out of printers, and, like, she spins it all up, and, like, and it's just office paper. What a waste! Is just, like, really funny to think about.
It's your fault. The office paper you use is destroying the planet.
Extremely 90s, and I just it's just
this episode sponsored by.
It's just the best.
Exxon.
What radicalized me? All cartoons in the 90s. That's pretty much what radicalized me.
Yeah.
No one under 30 knows what we're talking about. So anyway, so as usual in some of these kind of strange questions, we had to build some parameters. And the first one is spaces. What is a space between a word? Is the space around the word counting as a space?
So deeply poignant.
Well, because in digital typography, there's the M space, which is a lot longer, like an M dash, all the way down to a hair space, which is extremely tiny. And so I'm just assuming they mean one space bar press, right? And again, digital typography, that can vary roughly in size, but we're talking about the technical term for it is actually word delimiters or word boundaries. And then returns are new lines, or like a paragraph break if you're getting super digital about it. But I don't necessarily think that this is a super digital question, because we're really talking about, again, saving physical paper. And when it comes to that, I think we really need to think a little more outside of the screen. Also, really quick, another parameter we have to set. You would think, as Gerald says, that Japanese doesn't actually have spaces between words. Neither does Chinese or Thai. So we're really focused, I think, again, on like an English language. And we're trying to save paper in English printed situations.
If I remember correctly, the invention of the space was like a big innovation.
It was a really big innovation. Yeah. It came about in about the 7th or 8th century. But the thing is, similar to you, I'm not an expert in linguistics or humanities. So I called someone.
A double journalism episode.
I double majored.
Double journal. Wow.
I called Joanna Drucker from UCLA. She's a professor of information studies. She's written books about graphic design, typography, art, humanities. She used to teach design. And I asked her about digital versus print type, actually, to start.
This is, my ancient history, but I worked as a typesetter in the 1970s on first generation typesetting equipment. Had no memory, right? You typed, you got a film strip out and so forth. But it was a moment of transition between typewriting and a digital type.
Yeah.
And digital type, like the advanced IBM typewriters, has variable spacing. So the spacing from one letter to another depends on the width of the letter. So if you have an I or an L, you don't want the same amount of space as for an M. And it's not so much the space between letters or between words, but the space for the letter itself. I'm an M,
Yeah. Nice and wide, whereas a little L, skinny little L in there.
Skinny little L. But poets often write with a very acute sense of the alignment of the words in their texts. And they would come in because they all had typewriters that they were using to produce their final manuscripts. And they would want the alignment in the digital output to match the alignment in the typewritten script. And it was almost impossible to do it. And you had to explain to them that these two technologies understood letters and spaces according to very different parameters.
Wow.
We had a lot of struggles.
Those poor poets, man.
Those poor
struggling, tortured poets. In their department.
I feel for them. I feel deeply. Not as deeply as they feel, but I feel deeply for them.
Not even close.
I bring that up first to say we're already saving paper. By switching from typewriters to digital, we're already reducing the amount of space.
By abusing poets and making it so they can't print their exact spacing as liked.
Right. We're saving.
Right, okay. But
we're
you
saving
mean
some
by
paper.
Not printing as much stuff in general.
We're not printing as much stuff also, but yes. So I asked her specifically, though.
Bullying poets.
If
Save
you bully
the
poets,
planet.
you're gonna save the
Bully
planet.
a poet.
That's they'll thank you for it.
Captain Planet just punching a poet.
Stop rhyming.
Shout out to poets. I love poets. I
Same.
appreciate your art form. And
it's so
I
good.
understand that the visual alignment of the text is actually important to conveying the emotion and the message that you're trying to get across. I do.
It does make you think about like poets from the 70s that you read their stuff and it is all typewritten and you're like, why isn't it all typewritten? Is it just typewriters? And it's like, no, there's a lot of visual aspect to it. Anyway, that's neither here nor there. It's not really about spacing. So I did ask her just point blank, where did spaces come from?
So there didn't used to be spaces in Western writing. So Greek and Latin were written without spaces in what is called scriptio continua, and that held up until about the 7th, 8th century. And the theory is that because so much of communication was oral, that these texts were being read aloud. They weren't really being read silently or privately. So the opportunity for pronunciation came from the process of reading slowly. But the standard literature suggests that around the 7th or 8th century, monks who were working in Ireland, Celtic monks, whose native language was neither Greek nor Latin, had more difficulty being able to read those languages without spaces. So they started to separate the words to make the handwritten text more legible. And it's also around that time that private reading began to be a mode. So people would read, silently. Before that, most reading is oral and
Isn't that cool?
That is cool. It also makes sense that the Greeks didn't use spaces. It explains Greek last names.
Yes, it does.
I say this as my mother's side of the family is Greek, right? And so one of the names on that side is Dimitrokopoulos, for people who don't know. Greek last names do go on.
They do
are
a little bit.
Scripto continuo or whatever the term was.
Continua, yeah.
Yeah, they go on.
If you imagine scripto continua, right, you're thinking ancient Greece, ancient times, and they have this piece of paper or whatever, and it's just a constant block of writing, like we were joking about earlier. So you have to, while reading aloud, which is typically what would happen with something like this, interpret where words are ending and starting. So if you're thinking of English, sometimes a word will end in S, and sometimes a word will start with S. So while reading, you have to interpret whether or not this is a plural word and the next word is about to start with an S, or if, the opposite, and you need to end it in a singular and start the next word, whatever it is.
Now I'm thinking of the episode I did with Ralph about the Library of Alexandria.
Right.
And based on that time period, that means that there weren't spaces in all the scrolls yet. And maybe they weren't reading out loud, but if they were in the Library of Alexandria, it'd be a very noisy place.
Yeah, that's actually really funny to think about, because what I found is essentially that private reading or reading in your head was too difficult. Like, words were written to be spoken aloud. You weren't really silent, like we picture like these monks silently illuminating manuscripts. And that's somewhat true, but by the 12th century, spacing was standardized, but there are several kind of quotes and things of people who were like surprised and kind of shocked that people could read in their head. They would literally write it down and be like, oh, I came upon so-and-so, and he wasn't even moving his lips while reading the manuscript. Because they may not be speaking aloud, but they have to really interpret what they're looking at. It's not as obvious as it is when there's a space in between, and you can just like Dave Matthews says, the space between, those wicked lies. You just really gotta pay attention to that. Basically, from when the Irish monks invented spaces in our language, there were already spaces in like ancient Hebrew and stuff. And hieroglyphs had spaces, and a bunch of others had kind of delimiters in between, whether it was a dot or something else. But in English, at least, they started to add these spaces to make it easier for them to understand, but they didn't always add them in the right places. It depended on who was writing it down when spaces were added and where they were put. What is a word that you'd only ever seen written and then said it out loud, and we're like, oh.
Miscellaneous. I got clowned on that one.
That one's good.
It was like a junior in high school. I said it to somebody, and he was like, "Do you mean miscellaneous? You idiot!" And I was like, "Oh shoot, maybe I do."
Chamomile.
But the C, it's so subtle in miscellaneous.
Chamomile.
Chamomile. I think if my wife saw, she was playing like Stardew Valley and fishing, and she caught a tilapia, and she was like, "What the heck is a tilapia?" And I got that. Great. And that's the name of that fish forever now.
Tilapia. I love it.
It's a tilapia.
Yeah. This is common. Now imagine no one has ever said this word aloud anywhere near you, and no one ever will. Right. So you have to decide where the spaces are in between an entire sentence of these. Right. So it's like, that is why they're kind of random.
And you're copying a book, which means like this is a painstaking effort that'll take years and years and years.
Right.
To make an incredibly valuable item for the monastery.
So every scribe would put them maybe in slightly different places. And so they would be slightly different. By about the 12th century, like I said, they started to standardize spacing. And then we could start to, again, read silently, which is super cool. The podcast, The Illusionist, which if you haven't listened to, it's so good. It's a podcast about words. And they talked to Kate Wiles from History Today. And she says, quote, "Ancient Greeks put markers between their words. There were all sorts of different kinds, straight lines, dots, and Egyptian hieroglyphs had little markers to say the start of the word, which is the same as dividing up words to indicate this word begins here and the next string of hieroglyphs is the next word." But even with all of that in mind, as time marched forward and we got the press, the typesetting that Professor Drucker brought up, even with specific and standard spacing, every book, newspaper, and magazine were all written differently. And they're written with different ideas of what the spacing should be, and the different numbers and delimiters and boundaries and designs and layouts and typefaces. And that got me thinking. When I was a kid, I grew up in a quite religious part of the country, and I saw this book series called Left Behind.
I know the one.
Have you heard of the Left Behind series, Julian?
The people who weren't raptured. And
right.
They're left behind on Earth during the apocalypse.
On Earth.
Yeah.
And look, this book series, I'm not going to say it's good, because I don't think it is. But it is interesting that I can make fun of it right now. So I'm going to.
Okay. I'm not going to stop you.
So here's book one. I want you to describe it for our viewers at home. And by describe it, I mean describe the margins and spacing.
Oh, okay. Pretty small margins.
Yeah.
They were using this Left Behind author, say what you will about the message of the books or whatever, but they were on board with Gerald wanting to save paper.
Yeah.
Because it's a big blocks of text.
Yeah, the paragraphs are almost as tight as the line breaks. There are some paragraphs where you can tell that they don't use the rest of that line, but then the next line is right there. Mm-hmm. They're almost right up to the edge of the page. And this is actually quite a thick book. It's a couple hundred pages. And if you look at a set of Left Behind books, they all are about the same thickness. And I think that's the thing that publishers like to do. They want to make sure that the books don't get smaller if there's less for the author to say, which is why this is the 16th book in the series.
Yep, there's a little more breathing room. See, what happened was a lot of the letters got raptured, and so these are the words that are left behind.
Maybe 99% of the story was already done in the first book, and they're like, wow, it did so well, we got to keep writing
people
them.
like it, we better keep going.
Anyway, I thought that was very funny. And so it's funny that I had written that in my script, and then I talked to Professor Drucker, and she blew my mind, even having already thought of this.
Get ready for this. Okay, here's a book. This book happens to be, I measured it. It's about 5 by 7.5. See those margins?
Yeah.
Not very big, are they?
No.
That's kind of stingy looking, right?
Yeah.
Okay. Now, let me tell you. Let's talk real estate. How big is that page in terms of square inches? It's about 38.5, okay? 5 by 7, a little more. 38.5. Guess how big this text block is? What percentage of the page do you think is taken up by the text block?
Okay, I'm pausing it here so you can do the same thing you just did. Would these margins be more or less than what we just saw in, like, the 16th book of the series had probably like 3 centimeter margins on all the sides,
right?
Whereas like a 2-inch margin, and the lines were really far apart. Whereas the first book had maybe less than a centimeter margin. I would say this is closer to like a centimeter and a half, 2 centimeters. Like it's not big. Would you agree?
Yeah, the margins are small.
Right.
The text is a more significant amount, like a bigger percentage of the page that's available.
Right. What percentage of the page would you say that is?
Oh, 80, 85?
I would say off the top of my head, 80%, maybe.
Okay.
Yeah! Just saying that we just picked the same thing.
Oh,
so
yeah, let's
that
go.
is very validating to me.
Good brain. Love your brain.
You are so wrong.
No!
the text block takes, don't you love it?
I do.
It's 21.6 square inches, which means it's almost only half.
What?
Yeah.
And you just wouldn't think that.
No,
Right?
definitely
It's like if you
not.
were a kid and you were sharing your room with your sibling and they said, oh, you can have the center of the room and I'll take the edges.
Right.
You'd think you were getting a good deal. But, check the math on that arrangement.
Wow. So all book publishers are robbing us blind. They're all...
Yeah. I mean,
Apparently, even if it looks like a good deal, which is how I shop for books. I go and look at the one that has the most words per dollar.
that's funny.
That's how I know a book's good.
That's how you know it's going well.
That's a good book. More letters
So
per area.
what she ends up saying is,
Here's one with nice, generous margins, right?
yeah.
Okay, this is a bigger book. And you do the math on this, and it turns out that this text block is essentially half the size of the page in terms of area.
I would never have guessed that.
I
Like
know.
looking at a page,
I know.
I would never have guessed that it's only half. That's wild.
It's a very fun exercise to do. I taught design quite a bit, and you do this exercise, and students are kind of blown away because it's like, what?
I mean, I'm blown away.
The only way you are really going to save paper is not by squeezing those little words together so they're unhappy in their relationships. It's by getting rid of the margin.
Can I share with you something I think is hilarious?
Yes, please.
You might have seen this in my Instagram story after the holidays, but so there's a hockey player that's my current obsession. He's 19 years old. His name's Macklin Celebrini. He's very, very, very good, right? And he plays for my team, the San Jose Sharks, the team I root for. I don't own them.
Sure.
Anyway,
your team.
My wife, knowing this, got me for the holidays his biography.
Okay.
And he is, to repeat, 19 years old.
Oh no! So the spaces
the
between the
biography
lines
looks like this.
Yeah, it's a lot. Well, you picked a chapter start, but oh my god, you picked another random page and it's also half blank. And another random page and it's also half blank. Oh god! Oh my god! You picked 4 random pages and there are 5 random pages.
Planet is rolling
Every
in his
single
grave.
one is half blank. Not a single one is totally full. That is a strategy.
The margins are enormous.
Enormous. That's so
The
funny.
font is huge.
That's
That's
really
how
great.
you write a book about a teenager.
That's great.
A biography.
That's really funny.
The pages aren't even numbered, I assume out of shame. I can't even
Wow.
tell you how many pages
They're
it goes
like,
up to.
this is an 80-page book, but it's really a 5-page book.
Probably fitted on a leaflet.
They did exactly what we all used to do in college, which is like, double spaced? How about 2.1?
Oh, I need to write a 2-page paper? No.
Yeah, I'll do it a 2.1, not double spaced, a little extra. 12-point font? No, 12.5-point font. Make it a little bigger. Like, then I'll fill
Children.
up more space.
This is what we had to do before a robot just spat something out for us.
Yeah, true.
We had to be ingenious.
Yeah, we had to manipulate with what we could.
We had to creatively figure out ways not to write something.
Yeah, exactly. Which is why I'm also not that worried about college students using LLMs. I'm like, of course they are. We used word processors and had dictionaries and encyclopedias and all on the internet, and we used those, and everybody was like, Wikipedia's gonna ruin college!
At least you had to internalize the information before turning around and putting it on the page, you know?
I mean, yeah, you kind of did.
Now, my favorite genre is like the ones where the prompt is still in the paper at like the very top. Like they didn't
Those
even
are great.
proofread out
Those
the
are
prompt.
excellent. So we can't anticipate every terrible book with every huge margin. So if we're really, let's assume we've done the most we can with all of the things we've talked about. We've reduced the margins to nothing. We've reduced everything we can, and now we've just got the spaces between the words. The real question they're asking is how much of the page are those spaces? So I found a study from Mark Meisner in the 1960s where they took a bunch of newspapers, magazines, and books, and they picked a random spot from a sampling of those things and started counting. And they counted 200 words in a row, and they did that 100 times. So they ended up with these 20,000 randomly chosen words. They punched those into Hollerith cards, which are just punch cards for old computers in the 60s, and they used a card sorting machine to get inferences from that data. They broke this down and found that the English language, the average word length is... Any guesses?
5 letters.
Close. Yeah, actually, really close. They got data basically about a 3 to 7 letter spread, and the average was about 5.1 letters.
Yeah.
In 2012, Meisner, now retired and in his 80s, reached out to a guy named Peter Norvig at Stanford because researchers never give up. And he was a research director at Google. And Meisner was like, you ingested all them books. Google Books? You got it. You have a huge data set of scans of real books. For those unaware, back in 2002, Google had that slogan, don't be evil. So they just started scanning books under Project Ocean that they got from libraries and donations. And they scanned them into a database to like basically have the biggest collection of knowledge in the world or whatever. And they OCR'd them so they were all searchable. Really interesting how they did it, by the way. They didn't what you would normally do, or like what Anthropic and Meta and all these companies did when they made their LLMs with training data, is they destroyed the books. They like cut them apart and scanned them. Google didn't do that. They created a LiDAR scanning system that could tell how curved the page was. They would set the book open and then have a human turn the pages and use a foot pedal to scan the page with, again, a LiDAR scanner so that they could then decurve the page later. And that meant they could do really sensitive books that couldn't be destroyed, which is kind of awesome.
Yeah.
Again, back when they were Don't Be Evil. And they created Google Books in 2004 and then launched the Ngram Viewer in 2010. The Ngram Viewer is a linguistics database. It's fascinating. If you've never used it, you want to know like the prevalence of certain words throughout English history, dating back through all the books that they've ever scanned. Really, really, really cool stuff that you can go and look. So Norvig used the Ngram Viewer, found and downloaded the entire, because he worked at Google, the entire books data set, which was like less than 30 gigabytes, surprisingly, but still quite big. It's 97,565 words used 743.84 billion times. That is the English language that they have scanned. They broke it down in all sorts of neat ways, and they found very similarly that most words were between 2 and 7 letters long, and the average was about 4.79 letters per word, which is pretty awesome.
Yeah, a little lower, but still hovering around the same place.
Yeah.
You know?
So I think if we go today, we get about 5.1. And actually, if you Googled it, you would get 5.1. And this comes from, you know how they say you should drink 8 glasses of water a day, but nobody really knows where that came from?
Yeah,
That's
right.
where this 5.1 figure is. If you go to, I found a study, and everybody points to this study of social evolution and history from 2015. The average word length dynamics is an indicator of cultural changes in society, where they looked at English and Russian word lengths to see how social changes over time paralleled the change in language use, and how as words got longer in the 1960s, 70s, and 80s, words like discovery and evolution and experimentation were becoming more well-known and understood, and then words started to get shorter again in the late 90s, early 2000s, which it's very fascinating. But their citation pointed to like word length averages being 5.1, and it was literally in their paper, they asked Wolfram Alpha, And Wolfram Alpha was like 5.1.
That's it.
Yep. And Wolfram Alpha does not cite where you got it. You can go ask Wolfram Alpha and it'll just say 5.1, but they won't cite where that's from. I even went to LLMs and I said, tell me how long the average word in your data set is. And they're like, yeah, I don't know that. They're like, I don't have access to my data set, but I can tell you that this paper from 2015 says 5.1.
5.1.
And I was like, all right.
I had that thought process, actually, it's funny, as you said that, of like, oh, LLMs that were trained on a huge amount might know it, but I also doubt the LLM's ability to really understand and then execute what you're asking.
Yeah, the LLM actually doesn't know. So it's interesting, actually. This is a total sidebar, but I did look into it. LLMs don't know in part because of tokenization. The words are broken into chunks, and those chunks are analyzed. It's not necessarily the chunk of a word either. It can be parts of a word, including a space character. It can be parts of two different words. They tokenize them, and then they chunk them out to compute them. And they do this with the data set ingesting as well. And so it ends up, and it's a very different way to think about words, but it's how they do it. And actually, Professor Drucker and I talked about it a little bit as well, where she talks about how this tokenization is not a new concept. It's been around for a long time, and it has to do a lot with how we think about words from a computer's perspective, because they don't understand the context around them. However, I did ask an LLM, what happens if we remove all the spaces? Would this make your job easier? Could an LLM do the job just as well without spaces? And they said no. They were like, no way, because the tokenization would be much more confusing. Because delimiters, like with people, tell you where the meanings of things kind of start and end.
Right. Where the limits of the word is? Yeah.
Exactly.
Yeah.
So let's go with 5 as an average. Then we just have to do the math. That's simple enough. So if you have a word that is 5 letters, there's always going to be a space after it. Even the end of a line, sure, the end of a line, there's no space after it, but there is a period and a space before the next sentence. So I think we can assume that there's almost always going to be a space near 5 words. So then it's just math. It's just like, okay, cool. So 1 out of 6 is space. So you're saving only 10 to 15% of a page if you remove all of the spaces. That's actually not that much. And if you were thinking about paragraph spaces, as we recall from some of our margin discussions, the lines can be quite tightly packed, and you might miss out on some of the ends of some of the words, and chapter headings usually have like lots of space. But even that is only maybe 1 to 2% of the overall book. Let's round it up to 4. So then we could argue, cool, 15% space savings, 1 out of 6 letters, if you will, is a space. And then there's a bunch of other 4% of the rest of the book is empty. That's a 250-page book that is now 200 pages. But inside of that 200 pages, there are no spaces and no returns. So it's an extremely difficult book to parse.
It'll take you a lot longer to get through the physically shorter book.
It is 50 pages shorter, but those 200 pages are hard to read. And if you take all the margins away, now you're down to a 100-page book. You take the other 50% of the pages away. You have a 100-page book, and every square millimeter of the page is a letter.
It looks like the manifesto of a lunatic.
We're back to the 6th century, and the Irish monks are like,
What is this?
What is happening?
Reading it, I'm sorry, but in my head I would be like, and then Jane went to the store and she bought a can of Coca-Cola and then she went back. Like, it would just be continuous.
Oh my God, it'd be awful.
With no feeling, right? This feels like a 99% Invisible kind of episode too.
Yeah.
Like that kind of hidden design that goes into typesetting.
Yes.
That imparts meaning that we don't think about but intrinsically understand.
Absolutely. Have you ever seen the term, it's Etta Owen Sherdlu?
Oh, Etta Owen. Yeah, I went to high school with Etta Owen Sherdlube.
So, not lube, just Lou. Etta Owen Sherdlu.
Oh, I don't know Etta Owen Sherdlu. I'm sure she's lovely.
So, these are approximately speaking, the 12 most common letters in order in the English language, E being the most common, T being the second most, A being the third most, and it's used in typesetting machines. So if you think of it as a keyboard, this is the QWERTY. It is the first 2 rows on the far left of the typesetting machine are Edo and Sherdlu, and they're just that way. And so this is sort of like a funny meme that you can see in newspapers throughout history where a typesetter will just type Edo and Sherdlu to fill in space, waiting for something to happen. They never go back and fix it, and
Right.
it actually goes to print this way, and you can find it in like newspaper archives and things, and it just is like the lorem ipsum of the typesetting system, which is just fantastic. That is one of those little things that as soon as you know it, you're like, this is cool, this is fun.
Or I wonder if it even might be like an inside joke, like the Wilhelm scream in film.
Yeah.
You know?
But for the publishing business, they're just
Exactly.
like, there's a Sherdlu in today's issue.
I snuck one in there, yeah.
That's funny. Yeah, probably. So to really know how much paper we're saving, we have to know how much we're producing. Paper production is about 400 million tons a year globally. The U.S. consumed 93 million metric tons of paper in the year 2000. Today, it's more like 50 million metric tons. So paper is already declining with the rise of digitization. Consumer habits have changed. We don't print out literally everything that we do. You know, I'm sure CVS is keeping that number up with their receipt length. But everybody else is like, let's use less paper. Also, recycling has increased, which means we're making less paper from scratch. We're recycling paper and reusing it. According to Statista, we're up to 67% in 2023 of recycling for paper. But it seems like if you chop 20% off of that, that's a big savings. However, it's not, because most of this paper consumption is not in written documents. Most of it is in packaging and paperboard. Cardboard is made of paper. So when we talk about 50 million metric tons of paper, most of that is for cardboard, paper bags, paper packaging, and not books, even though we do print a lot of books. So would we save some paper? Yeah. I mean, I couldn't find statistics that broke down paperboard and cardboard versus printed, like printer paper, books, and things like that. But let's assume it's 20% of the total is printed paper, magazines, newspapers, and books. Let's even assume half. 25 million metric tons is quite a lot. Cut that in half to make everything less readable and less easy to parse. And we would be saving 25 million metric tons, which is fine. We recycle most of that anyway in a year. So I am a big proponent of environmentalism. I think there are things that we do where we're like, no, I'll get a plastic tree rather than cut a tree down. It's not actually helping. The plastic tree goes in a landfill forever. The Christmas tree or whatever, the tree that you put in your house during the holidays was grown at a tree farm specifically to be used as a Christmas tree.
Right.
And will biodegrade when you are done with it. Is it wasteful? Argument, agree. Is a plastic tree less harmful for the environment? 100% it's not. But we would think of it the other way. We would be like, oh, I'll have this tree, I'll use it for 10 years. It's like, right, you save 10 trees. Then you put that in a landfill for eternity.
And the landfill is festive forever. Okay.
Think of the plastic tinsel.
Think of the holiday spirit will never die now. With your, again, nonsensical tradition, as we have covered.
As we have covered. So I think it's one of those things where, Gerald, I think you're right. We could save paper. We would reduce use, but not a lot. 10% if we just remove spaces. Maybe 15%. Maybe 20% if we're being really generous. And yet, we sacrifice the readability of everything in our lives in order to do that. So I don't think it's worth it, personally. But you do you, you know? I'm not your dad.
Yeah. Plus, how would people write biographies of 19-year-olds?
They could. It would be more of a zine.
Real brief.
Lots of pictures.
Yep. Well, thank you, Trace. What cool experts you found.
Yeah, and you as well.
She was awesome. I mean, that's
she was really good.
Again, he's family. I get to bother him whenever I want.
She emailed me today and she was like, that was fun, in all caps. And I was like, she's great.
She seems super delightful.
If we need any more design questions, we should just call her again. She's awesome.
So cool.
All right, well, you've reached the end of another episode of That's Absurd, Please Elaborate.
Congrats.
Thanks for making it here. Should we do this all without spaces? Thanks for listening to this episode of That's Absurd, Played with Loud. The show is created, written, produced by me, Trace Dominguez.
And me, Julian.
Today's show is produced and edited by the wonderful, and he actually has a lot of space.
Yeah.
And really has created space.
His
around
legal
himself.
name has 3 spaces before and after each
It's actually, his
name.
legal name is Kyle Sisk. And today's show is associate produced by Sabrina Capello, and our music thank you to Epidemic.
Thank you to those who submitted for questions featured in this episode, Stephen and Gerald. If you'd like to submit questions featured in the... Okay, I'm going to actually slow it down because it's important. This is important information
important stuff
for us. Thank you, Stephen and Gerald. If you would like to submit questions, you can look for the form down in our show notes or email us at hello@that'sabsurdshow.com, no spaces in the URL, or visit us at that'sabsurdshow.com/ask, or call us at 302-TAPE-SHOW, that's TAPESHO.
You have to consciously try not to
I am
sing
fighting
the song this time. I know, it's really hard.
Talk about also a name... Like, I've read it, and I'm still not totally sure how it's said. Chapel-roan? Chapel-roan?
It's Chapel-roan. Yeah, you got it.
Oh, with a ch?
Yeah.
Okay.
It's not Chappelle-roan. Very fancy, but that's not it.
We love these questions. We couldn't do them without you. We appreciate them so much. Thank you to our patrons over on the Patreon. Our absurd administrators are Adam, Les, Austin, Jonathan, Dan, Sabrina, The Brain, Hannah, Apothecarian, Christina, and Atomic Straw. Happy anniversary or milestone to Christina, 3 months, and Shane for 1 whole year. By the way, Shane, I'll have to share it with you, sent me a website he built.
He sent it to me as well. It's a fan website of the podcast. I think we should put it in the show notes and everybody can see it.
It's bonkers.
It is unhinged, Shane. We like it.
Which
it's
is us.
absurd.
That's our brand.
I'd like everybody to see it because your blurb is excellent.
So funny. Shane is single-handedly trying to reclaim my status as co-host, as the less loved co-host.
You're not less loved. You're equally loved. You're just less reviewed.
You just review more poorly. Test audiences just don't like you as much.
You're more of a like a
an
acquired host taste.
Also, thank you to our newest Patreon subscriber, Charlie Victor. Thank you, as always, to those on the Patreon. Again, it lets us do a lot of fun stuff. It's kind of been the only source of income for this podcast for a long time. And also, we just appreciate you all for jumping in and supporting this goofy endeavor. It's just a really sweet, cool thing for you to do, and it does not go unappreciated over here.
Also, as long as we're thanking people, thanks to those who are listening on Nebula. Nebula is a place where you can go and support creators that you love or learn about creators that you don't know yet that other people think are also awesome. Nebula is a streaming service, and of course, they have all sorts of other independent creators that you can watch, and just by watching them, you support them. It's a place where creators can try things without having to worry about like the YouTube algorithm hitting them for doing something that maybe is outside their wheelhouse. And I have done that over there, and so have lots of other creators that you might know and love. So to join, visit go.nebula.tv/that'sabsurdshow, and we'll get a little bit of credit if you join using our link. So thanks to those who have. I know a lot of you have already, and I know there are a lot of listeners over on Nebula, so shout out to you all. If you want to see clips from the show and share them with your networks, go to That's Absurd Show on Instagram, where Sabrina is making us look ridiculous, and we love it.
She does us so dirty.
I loved my mint julep and my hat.
It looked real good on you.
It was great.
It really did. Well, Trace, what do we say at the end of every single episode?
Don't do it! Yep. Don't do it!
Give it plenty of space.
Don't do it!
By leaving it outside the pool. Don't do it!
Don't bathe with toasters. And also we'll say, this is Julian. He's a communicator focusing on the field of science. His most impressive feat to date is being awesome. I really tried to find something funny from his past, but I couldn't. Here's a great picture of him instead.
Aww.
That's from the National That's Absurd Please Elaborate Appreciation Organization, created by Shane. So thank you, Shane, for that.
Very, very silly.
So silly. Thanks again for listening. We'll see you all next week with another episode. Bye.
I'm gonna go take a bath.